This little tape right here contains one of the rarest versions of BASIC I've ever come across. It's called BURP, or the Basic Language User Responsive Program. Now, by all accounts, it's essentially just Dartmouth Basic, but this one was custom spun up by EDAX Laboratories, and it contains a couple of extra features, like a desk calculator mode and a couple of extra statements specifically for interfacing with an EDAX 707A X-ray spectrometer. So as far as I know, the only existing copy of BURP anywhere in the world is right here on this cassette. So it is absolutely paramount that we get this cassette backed up as soon as possible. However, it is not an audio cassette, which means that the only way to back this cassette up is to use the appropriate TechTran data cassette drive like this one right here. Unfortunately, this one is currently broken. This TechTran Model 8410 data cassette drive is a piece of a larger puzzle that I'm trying to get built in time for VCF Southwest, which is coming up frighteningly soon. But that puzzle includes this TechTran tape drive, the Data General Nova 1210, and a data terminal of some type to go with it, whether that be the ADM3A I'm currently using or a Model 43. Both of those seem to be working quite well. And the Nova 1210 seems to be working quite well, which just leaves this 8410 tape drive right here. Now, in the previous episode, we did actually get to work on this, and we could see that it is writing data down, but it's not reading any data back. And data seems to be passing through, but it's getting garbled. However, that garbled transmission thing seems to have solved itself, so probably it was just a cabling issue. Once I plugged in a real deal terminal to it, everything kind of smoothed out. So it was either cabling or voltage levels were unhappy, and either way, problem solved. It all seems to be working great now, except we never get data out of it. And a lot of you guys asked a really great question. Is it not outputting data, or is it not writing down data? I can pull the tape out, put it into an audio player, and see the data that's been written down. So the write is working correctly. It just means that we have a fault somewhere related with the read circuit inside of this drive. And that's a bit of a problem because we need to back up the data on this tape. There's BURP as well as 7EP. These are unique EDAX built applications for working with a spectrometer. And as far as I know, this is the last known surviving copy of that software anywhere on the planet. So it's vital that we get it back up. But I can't just put it in here because the read doesn't work. And also, I can't just throw this into an audio player and record the audio file because this is not an audio cassette. And it took us a little bit to figure out exactly what it was. We did have the user manual here, but this is vague and Spartan at best. So we needed something a little more in depth. And this is where a legend by the name of Rick reached out in the previous episode. Rick happened to have a copy of the Model 8410 technical manual. And after reaching out and getting in touch, Rick scanned it for us and sent over the PDF, and it has been a godsend. This thing is full of unbelievably good information as well as full schematics for this tape drive. But we also learned that this is not your average ordinary audio cassette drive. This thing has 2 tracks that span the entire width of the tape. One track is data, the other track is the clock, and it is laying down raw flux transitions on the magnetic material. This is a proper, real deal data mag tape drive. As soon as I figured that out, I just fell immensely in love with this drive. I don't have a real deal mag tape drive anywhere in this room, and now if we can get this one going, I will. Before we get too far ahead of ourselves though, the new manual also has a nice schematic for the power supply. So right quick, let's run through and check all the voltage rails again. If any rail looks out of spec on the multimeter, I'll circle back around with the scope and check for ripple. But honestly, they all look absolutely spot on. I'm betting the power supply in this thing is totally fine. So we're not getting any reads out of it, and if we look at the schematic, we can see that we should be getting data on test point 4. So it's kind of them to put that in a pretty easily accessible place. So we'll just hook the scope probe up to that. The power is on. We'll go ahead and hit read here. We can see we're sitting at about 4 volts right now. And nothing. We never get any wibble wobbles on 4. So we definitely have a fault somewhere. We're working our way backwards from test point 4. I wanted to check pin 5 of IC19, but actually I'm on pin 7 of 26. These are just connected together though, so they should be exactly the same. So let's go ahead and we'll flip the power on here. I will do a single shot and then we'll click run or read. Yeah, that's just dead, totally dead. Okay, so we need to keep moving our way up the line. All right, we're looking at pin 2 and pin 3 of IC26 now. These are the 2 inputs to this LM311 here. And we know that we're not seeing anything on the output. So we want to see something that makes some kind of sense on the input here. So we'll do a single shot. I'll flip it over to read here. Yeah, all right, there we go. Pin 3 is wibble wobbling, but pin 2 is pretty steady state. However, pin 3 is crossing the threshold of pin 2, so that should be causing the output on pin 7 to be doing something. This little guy right here is the one that I think has gone bad. This is an LM311, just a little comparator or op amp or something like that. Unfortunately, it's not socketed, so we're gonna have to desolder it. Fortunately though, it's only 8 pins, so desoldering it shouldn't be too brutal. So I'll flip the entire PCB over and add fresh solder to all 8 legs of the IC. Then I'll get my trusty desoldering iron out and go to work. Although I'm afraid I'm gonna have to decommission this workhorse before too long. I can't seem to find any new tips for this desoldering iron anywhere, which is an absolute shame. After desoldering the IC, I'll just pry back and forth from the edges, and look how easily that IC comes right out. Man, I love this desoldering iron. I'll slip a new socket into place and then solder it down, making sure not to create any accidental bridges. And finally, let's pop a new LM311 into place. Our little LM311 here has been replaced, so hopefully we're gonna get data out of this thing. I'll go ahead and flip the power switch on here. And I've got the laptop set up here with Minicom running on it, so all I should really have to do is hit the read switch here, and we should read whatever binary is on that tape, and it should punch it out. No. Nope. Nope. Nerds. Let's try that again, only this time with the cables hooked up correctly. I pulled out my ADM3A to work as the terminal, and my laptop here is acting as the modem slash CPU. So let's flip the power switch on here. Now, anything that I type on either one should pass through if I'm not mistaken. So let's type hello. Yeah, there we go. Hello over there. And if I come over here and I type hello, we get it over there. Okay, that's excellent news. Let's start a write. I'm gonna do a Control R. We can see that the write light came on. I'm gonna do an Alt V. I've got some text loaded up here. I'm just gonna hit enter and let it send that text. We can see that text coming through on the terminal over there, but also it is correctly writing it to the tape. So this is excellent. This is fantastic news. That is amazing. You can see the text is being sent through completely faithfully, and every so often the tape jumps forward just a little bit as it fills up the buffer and then writes that buffer down to the tape. Okay, that finished. I gotta tell it to stop the write, and I can never remember what the key codes are for that. Control T should stop the write. All right, let's do a rewind. Control Z. Oh, it cleared my terminal. That's interesting. Oh, I think probably because the Control Z character code tells the ADM3A to clear. Okay, so that rewound. It did detect it at the end because I'm using a different tape here. So let's try a read. Let's do a Control Q and check it out. We're getting it. I'm getting extra line feeds here because that's how I have TerraTerm set up. That's not a problem at all. But this data is coming straight off of the tape. I think that our tape drive is fully working. Yes, how awesome is that? We can write data down to it and we can read that data back from it. I'm learning more and more about this thing as I use it a little bit while I'm filming here. And check this out, we're currently in online, and if I hit Control Q from the terminal here, nothing happens. But if I take it offline and I hit Control Q, check that out. It sent the command to read, and we're now reading the data coming off of the tape, but it's printing on the terminal instead of on the CPU over there, because that's what the online-offline switch does. If I do a Control S to pause that, we go back online, I can do a Control Q to start reading again, and it doesn't work. Go offline, Control Q, we continue reading. The next step is to try and back up all of the data on this tape, because this is not audio level stuff. It's raw flux transitions. And so the only way that we can back this data up is with a functioning TechTran tape drive. And it seems that this one is functioning. Now there are 5 files on here. The first one is the binary loader, but then we have 7EP, patch, burp, and frame with STDs. Burp is the one that I really want to save. This is the basic language user responsive program. But we'll start with the binary loader here. So we'll go ahead and take this tape out. I'll put the TechTran tape in. Let's make sure it's all the way rewound. It is. Okay, so we'll go over to TerraTerm here, and I'll do file log, and this first file is the binary loader.bin. It is a binary file, so we'll go ahead and click save. And now anything that comes from the TechTran to here should be saved by TerraTerm into that binary file. So let's hit read here. And I guess we'll keep hitting it until it finds some binary data. Yeah, there it goes. We can see TerraTerm's going a little crazy there. It is reading off of the tape exactly like it should, and I guess it finished that file. So we'll go to File, Stop Logging. We'll pop over to HXD here, and I'll do a File Open, and we want to open the binary loader. And I mean, I don't know what the binary loader looks like offhand, but that looks close enough to correct. I'm going to keep plugging away at this, and hopefully we can get all of the files. To be totally clear here, getting the data off of this tape was not easy. I've been working on this in the background for about 3 weeks now. And the TechTran is working brilliantly, but the tape itself was putting up the fight. We initially let it bake in the dehydrator for something like 40 hours, and that got us through the binary loader and most of 7EP, which was the next file on the tape. But as soon as we got into patch and burp, it would start squealing and sometimes even load down so much that the low torque of the motors in this tape drive couldn't push through it. So the tape would have to come out, go back into the dehydrator for another 20 hours, bring it back out, try to read again, and then I think in total, it probably spent over 100 hours in the dehydrator dehydrating, but ultimately, in the end, we got every scrap of binary off of this tape. It's all backed up and saved, and good. We know it's good, but if I haven't yet plugged the TechTran into the Nova, how do we know that the files that came off the tape were good? Well, the binary loader is an easy one because that's a known file. There's backups and archives out of it. And we confirmed that it matches those and it looks good. 7EP and burp are the two that we really wanted to save, and they're much more difficult. But I was working with a very brilliant individual on the Discord, Peter. I posted up the binaries in there, and Peter got to work with SimH, and we were able to pull up both 7EP and burp and confirm that they boot up and work correctly. But burp is effectively Dartmouth Basic, but it has a couple of modifications to it. It has what they're calling a desk calculator mode that allows you to execute some things directly from the prompt, and it also has 3 commands that are not in any other version of Basic anywhere on the planet. These are commands specifically for initializing the EDX 707A spectrometer interface, reading one channel and then closing the interface. Otherwise, it's a pretty normal Dartmouth basic version, but to have these extra git commands in there means that this flavor of basic doesn't exist anywhere else. The last known copy of it was on this tape, but it has now been backed up and saved in multiple locations around the planet, so we're never gonna lose it again, which is epic. So all we need to do now is write those values back down on tape, which I've actually already done. I've got the binary loader, BURP, and 7EP on this tape already. So we need to put this tape into here, plug this into the Nova, and see if we can load into BURP. But there is one extra problem. And this is the layout that I received: a Data General Nova 1210, the TechTran 8410 tape drive, and a teletype Model 43. And we were under the impression that this was a Randwin parked setup. However, there's some baud rate weirdness going on. The TechTran here is capable of multiple baud rates from 110 to 2400, but the Model 43 is only capable of 110 and 300. However, the slot saver card that's in the Nova 1210 is jumpered for 1200 baud. And since there's only a single UART in the TechTran, you can't have disparate baud settings. The terminal and the interface with the computer have to be at the same speed. So either we need a terminal that can do 1200 baud, which is why I've been using the ADM3A, or we need to pull our RS-232 card out of the 1210 here and jumper it for 110 or 300 baud so we can use it with the Model 43 teletype. I haven't decided exactly what I want to run with for the ultimate configuration, but for now we're going to stick with 1200 baud so I don't have to desolder and change jumpers on the slot saver serial card in here, and we can leave this at 1200 baud. Plus it's going to make things go a lot faster. At this point, I think we've confirmed that all three pieces work fine on their own, but let's see if they work fine together. So we'll turn the terminal on here. I'll turn the TechTran on here. And then finally, we will turn the Nova itself on. I got a little cheat sheet here that I'm going to follow along with. Our first step is to toggle in the bootstrap loader, and this starts at 05757. And we'll do an examine on that, and it looks like there's already some data in there. That's going to be a 126440. That's actually correct. I didn't toggle that in. That was already in the core memory, probably from when somebody toggled it in 30 years ago. Let's just burn through this and see if the full bootstrap loader is there. Yeah, 063610, 000777, 060510, 127100, 127100, 107003, 000772, 001400. Ooh, that's different. That should be 06110, but this is actually showing up as 01000. Okay, that's interesting. Let's check the next one. This should be 00476 is what it should be, but we're showing a 2. Okay, so that one's a little different. This one should be 044402. That's correct. And then the last one here is 004760, and it should be 4764. So our bootstrap loader has a couple of different instructions in it. But I'm going to go out on a limb here and say that maybe that's what it's supposed to be. So we'll go back to examine here, and let's just start running the bootloader and see if this works. So I'll hit start here. The bootstrap loader is running. We're going to switch you over to binary. Let's make sure the tape is fully rewound. It is. I'm going to hit read until I start getting binary data. There we go. It's reading in binary data. This should be the binary loader loading into memory via the bootstrap loader here. Okay, that finished. We're going to stop it, and then we're going to go to 0577777, and we're going to examine this, and we should see 000663. That's correct. That tells me that the binary loader has loaded in successfully. So we will start executing from this address, and then we'll hit read on here again until we start getting binary data coming in again. Yep, there we go. It should be reading in BURP now. Now BURP is quite long, so this is going to take a little bit here. Hopefully it loads in BURP and we see something show up on the CRT up here. Yes! Commas, 14 spaces, type Y or N. I think that means BURP is running. I have no idea why it printed it 4 times, but I don't know, who knows? Maybe that's what it's supposed to do. Let's go ahead and type Y here. And I think we're running. Let's do a print HELLORLD. Oops. We got an extra 2 in there. There we go. It printed exactly what I told. All right, let's write a little program here. Let's go 10 for I equals 1 to 5. 20 print hello world 30 next I. All right, let's do a list. Look at that, it auto indents. That's awesome. Okay, let's run this. Run. Oh, that's awesome. BURP is fully working. Let's try running something a little more complex and basic here, and it's been a long time since I've done anything in Dartmouth Basic. It took me a little bit to figure out how to get all of the variables set up correctly, but I do believe that this should work. And what this is Project Euler's question number 1, which is find the sum of all multiples of 3 or 5 below 1,000. Now I modified it a little bit to print a running total here, so it's going to run very slowly, but it should look really cool. So let's give it a shot. We'll do RUN for run, hit enter. There we go, 3, 5, 6, 9, 10, 12, 15, 18, 20, 21, 24. Those are all multiples of 3 or 5. Looks like it's running correctly. That's working. That's working correctly. That's absolutely awesome. No matter what happened today, it was a massive victory because we managed to get the data pulled off of this TechTran tape and safely backed up. And the good times just kept on rolling because check it out. The Data General Nova 1210 is sitting there happily executing a quite complex program running on BURP, a very custom flavor of BASIC for the EDAX spectrometer. And that BURP program was loaded in via this TechTran data cassette drive right here. And it all just works. How awesome is that? Also, this is my first proper mag tape drive in this room. I can't believe it took me this long to get my hands on a real deal magnetic tape drive, but I'm having an absolute blast playing with this thing. It's really cool. And if you want to play with it, this setup as it sits here is gonna be on display at VCF Southwest, sitting there churning away whatever basic programs people come up and punch in. Now, I don't know if I'm gonna run this ADM3A at Southwest or if I'm gonna run the Model 43 teletype. I think they're both really beautiful and really cool data terminals. So sign off in the comments. Let me know what you think is the coolest terminal to run with this, the Model 43 teletype or the ADM3A. But while you guys are signing off in the comments, I'm gonna sit here and play around with BURP because it's just such a fun programming language to mess around with. And maybe in the future, we'll figure out how to make proper use of those extra spectrometer specific commands. And maybe we can use those to control something external to the Nova. So I wanna thank you all so much for watching, and I hope to see you in the next one.